Okay, good morning. I'm redoing this part of last seminar because I forgot to hit record. So what we're doing in this first segment is to basically go over the homework assignment from before, which really is an integration of the knowledge hopefully you've been accumulating so far. So the homework assignment was to finish normalizing the card one abiotic data. So we want to be able to move site depth to a position table. And as I've mentioned before, I think um, for any type of sampling you do, whether it's fishery surveys or anything, your card one or the operations or abiotic table should really have minimal information. So if we follow normal form 2, we would need to move depths over. And typically with fisheries sampling, this position table should have a position that has a latitude, longitude, or UTMs if you're in a terrestrial system, and some attribute of that sampling event. So in the case of fishery sampling, it would be depth. And typically with a GPS unit on a vessel, you'll get surface temperature and time and these other things depending on the sensors you have on ship. So in this case, we're going to basically create a positions table. So there's two ways to do this. One, typically if you have data that you're normalizing already, not starting from scratch, you can actually start off with creating that table in your first iteration of a query, which would be a make table query. The other approach is to actually create this positions table from scratch and then move the data over by appending to it. Again, remember, appending is adding records, um, and updating is changing the values within existing records or cells. Okay, so we have two depths, and also the assignment was to create a position code table. So basically, with gill nets, typically there's a shallow and deep end of a gill net, and that's typically where uh, vessel captains will record waypoints, record the coordinates. It'd be like a terrestrial transect too, the ends of it, but sometimes there's a lot of intermediate measures. In this case, we're not going to have an example of that. But so we want to have position type 1 and position type 3 coded with these. So we're going to make a table, but again, if these were systematically organized, where depth 1 is actually the shallow end and step 2 was the deep end, this would be an easy exercise. So, but it isn't. If you look at some of these, they're actually back, so we don't know which one's the deep end. So we're going to run a query to evaluate that. So our first step is to basically go and create a select query with this table. So when we create the positions table, as you recall, in order to have a table, you have to have a key. So the foreign key would be the lift ID or operation ID that we want to carry over to the position table, and then the depths. So the lift ID and depths, and we would move the position to coordinates like latitude and longitude, but we don't have that. But we'll make that accommodation in that table later for future data. Okay, so let's just look at this. This is a select query, so we're not doing anything except looking at the data. So what we want to do is move these over to a positions table, but we also want to know the position type of each of these. So in order to normalize it, we wouldn't repeat this structure. We actually would bring site depth 2 down because it's going to be going downwards. So then we need to know the position type of each of these values relating to that lift ID. So what we can do is run a Boolean statement. So let's call it pos typ, and then we're going to evaluate the due depth. So if you recall, we are going to use the if statement. So in Access, it's IIF, and then we square bracket any field. So S depth 1. So if site depth 1 is greater than site depth 2, if that's deeper, right, greater value, then it's going to be a deep end. So we're going to assign it a 3. If it's not, then it's the shallow end. There's only 2 depths in this case. Then we close bracket. So I'm going to drag that out. And again, remember that you can create expressions here, or you can actually go into the builder with this little magic wand and it's there too. And then you can access a lot of the functions, but all we're doing is using the IIF function. So I already told you what that is. So with your functions and also your query layout, you always read it from left to right what it's doing. Basically, it's looking at the lift ID, site depth, and site tooth from this table, and it's everything because we don't have criteria restricting it. Then we have an evaluation field we created that is going to create a position type code for site depth 1. So this equation, this comparison is only attributing position type for the site depth 1. So we're going to run it. So looking at 110 feet, is that the shallow end, which is 1? Yes, it is. Is the 232 the deep end? Yes, it is 3, right? We're not looking at this one. It's comparing the two. In fact, to make it simpler, we can actually not show that, and this is actually what we want to make the table with on our first iteration. We're going to move the site depth 1, and we'll take a second step to move site depth 2. Then we're going to evaluate site depth 2, whether it's a shallow or deep end. There's probably another way to do it, but this way, is one way, so you get the gist of it. So again, we're all ready. We evaluated that. We'll just take a look to make sure the other depths are correct. So 1300 is the deeper end, and then 198 is the shallower end. So we're going to move site depth 2 and create a table. So now this is an action query, so you need to be careful. So what we're going to do is create a new table called C1 positions and hit OK. All right, so what this is going to do is going to, now we can preview it. We're going to move lift ID, site depth 1, and we're going to make an assignment of a position type to a new table called positions. So we're going to go ahead and execute it, run it. It's going to ask you, it's going to move 4 rows over. There you go. So you can see a positions table was created. It moved, it actually made a copy because they're not moved over. If you look at the card 1, it's still here. And we'll go back to that in a little bit. So we have a card 1 positions table. So now we want to look at site depth 2 and move that here. And we're going to, in this step, not make a table now. So we don't want to run this query back as a make table query. We're actually going to append, right? But first, let's go back to select query, take your action query and put it on save so you don't run it again. Because if we ran it as a make table, again, if I run it, it's going to overwrite the existing table because the action is to create a make table. So there's already one there. We don't need to do it. So we're going to select. So now we want to look at site depth 2 and make sure that's the deeper and make sure the assignments are relative to that. So all we have to do is basically switch the greater than or equal sign. So let's run it. So now it's looking at site depth 2 and say, is that the deep or shallow end? So if we go through, that makes sense. And then now we're going to move site depth 2 and repeat the action. So now we can close that off. We're going to check it. And then now, instead of making table, again, append is to add records. So we're going to append this. Now it knows it's the position table, so we're going to hit OK. So one thing I forgot to do, notice that when you go to append records or move things over, it automatically matches up field names. So make sure when you name everything in your database that the field names are consistent, because you don't want to have site depth 1 mean something different. Now, let's go back to the positions table. We actually don't want this called site depth 1. I should have changed the name in that query, but here's another way to do it. Just go back here. And we're going to say site depth, a generalized site depth. And also you should, so site map, and then you also should always put the units. And make sure you go back and fill in description of every single table so that you know what and this is of course position type code. And then this is lift or calibration ID. Okay, so now we set it to site depth. It's a long integer because you know that's a fine. It's fine at that type. So now we're going to go back. So it still retains site depth one because we haven't refreshed it. So in a database, if you make changes and you have things open like this, it's still caught up in RAM memory. I mean, one way to do it is to close it, and there should be a refresh button, but there's not. Um, so you can just change it to site depth because we know that's true. Now we don't want to, and in fact, we want to move site depth 2, right? If you recall what we did, we already did site depth 1, so we want to get rid of that. So we're going to pen lift ID, site depth 2, and then the evaluation position type. So we can preview it, and then we can go ahead and execute it, and we're going to pen 4 rows. So now, again, let's always say we have an append query. If we run it again, it'll add it a second time to the bottom. So let's look at the positions. So we have to refresh. There's a refresh button. So that's because I have it open. So you can see we brought the second site depth to here, right? So it's not the same depth. But again, there's a good example of what if you don't be careful, if you're not careful with an action query and you forget and you actually run it a second time, it will append these because we don't have a key to restrict this. So it's going to add it. And then if I go back here, notice it did it a second time, and you get clicking, it'll just do it infinite amount of times unless you have key restriction that says for every unique combination you can only have one. We don't have that in the positions table right now. So I'm just going to go ahead and delete this because you can't actually undo an action query. You have to go do a delete query because, again, in a database, everything's stored instantly to the hard disk. It's not like Excel or whatever where you have to hit save. So I'm just going to delete those because that's not. So we basically normalized the card one. So these values were evaluated, whether shallow or deep, and moved to a positions table. And they're still there. And then our position table is now correct. So one last thing I want you to do is go ahead and put position. So in this case, latitude, and then you want that as a it has a decimal. Typically, it's decimal degrees when you're working in the Great Lakes, so you want to use a single value. If you're working with terrestrial systems and you have mixed units, then you would have to basically either convert it. I don't know if I spelled that right. There we go. So let's say you have some sort of program where you have mixed units. Typically, I think if I think about this right, positions are Cartesian, x and y. So basically, latitude is the y value and longitude's x. So UTMs are similar. I think they're in meters or something like that in different coordinate systems. So you could put x coordinate, y coordinate, and then you call like basically a coordinate system. Then you can have a code assigned to, yeah, this is UTM, this is lat long. Then you'll know what unit it is if you have mixed units stored. Otherwise, you can standardize the units as latitude, longitude. And then again, latitude, longitude, because it's not like a metric system where it's decimal, it's like a clock. So it has to be based on 60. So everybody standardizes decimal degrees, which is easier, in my opinion. So, go ahead and do that, and always put C1 as notes. Always have notes in case there's something about that position. For example, at this position, found dead body. That at the shallow end. So you can make notations or something like that. So we moved that. So to recap, what we did is move the site depths from the card one abiotic data to a positions table, and that's normalizing. So the final step is just delete these fields here. Just go in here and then delete them. And then if we go back, now this table is normalized by moving those over. How to integrate access with R. So if you guys don't have this query, it's fine. You can see what I did. So I created, basically what we want to do is, if you did your homework, and you actually can just do it to this query, and I'll talk about how to do that. We basically calculated catch per unit effort. I think we got to that point for all these years or whatever. So what we're going to do is just simply plot the catch per effort by year, which is a standard thing we would do. So it's the density of animals or organisms by year, which is, annual trends and relative abundance. So I'm going to close Access quickly and then switch to RStudio. Hopefully I got. Are you guys seeing my RStudio?
Yeah.
Okay. So I sent you guys an R script. It's very simple, and I am not a R guru. I'm like a kindergarten R user, but it is very powerful. And once you get into it, it's not too hard to learn. So basically, in order to connect any R script you have, which could be anything from simple figures to complex stats, all you need is. What happened, Gord?
Just click the wrong button.
Oh, okay. So all you need is the RODBC package. So ODBC is a common function in computer systems relating to connecting objects, mostly databases. It was created, for heavy end data managers and data scientists. So all computers have it. You got to really know a bit about it to use it, and I know very little. But it is the type of connection built into computers so that you have large databases connecting to any type of front end software. So the way the next level works is you have a back end database, kind of like everything in the world, like that Google or Amazon has, and there's a front end interface, whether it's the internet or your purchase form on your app, or you can use Microsoft Access as a front end. So our agency has these large data sets, like stocking data or some other crap, and we're able to connect to that giant data set because those are SQL type people. But I don't want to loan that, but you can use Access and even Excel or any other thing to connect to them. So that's ODBC. So it's called Open Database Connection. That's all that means. And then R created a library for that. So hopefully, if you didn't have it, go ahead and install it, and then you run the library. So this just tells you I loaded the library. So what I did is I created a simple thing to connect to the query in Access called CPU-E4. And then if you don't have that one, you can just change that to years, the one that we did earlier. And then there's only 2 lines that need to connect to Access from your R software. And you can copy this and put it in every single R script you have and just change. Well, actually, you need 3. Then you just change the query. But if you have one database, it would connect to that. So I just ran the library. I'm going to show this object, which is connect. So this tells me right now it's connected to my database for this class. And then now I'm going to access it through SQL, right? It's using a structured query language to fetch from that database query CPU-E4. So let's hope it works. So it did it really fast. If you have a large query with like 1 billion records, it'll take a few seconds. So now I'm going to run this, which provides the headers and a sample of the data. So this is, if you recall, is what's in Access. So I'm going to just really I'm used to having to prove things to the DNR. So that's what it's grabbing dynamically. So right now there's actually a connection to the Access. And so if you're trying to do stuff in Access, it might act funny sometimes because R has a electronic connection to it right now, accessing that data. So then I just created a simple, you don't have to install any graphing packages. It's just the base R graphing, and hopefully this works. And so what it did is created CPUE over time. I don't know if you guys were you guys able to do that? I don't even know if you have CPUE 4. And if not, if you had a failed message, if you're doing this right now, like if this didn't work, you'll need to install a driver. And I just sent you a link to a Microsoft website to download that, or you might have to go through your IT department to install it. And mine did too. And I'm going to show you quickly if I wait. I'm not connected to the. That's not going to work. But basically, if you have a, well, actually, let's see. It'll just look like. If this works. Right here. Whatever your process is, if you're an agency or at the university, I'm guessing is the same. I sent you a link to directly download that, which shouldn't be an issue because it's a Microsoft site. But you just install this thing because it has something related to the drivers that support this. Has anybody else gotten this to work besides Sarah? Okay. All right. Do you guys have any questions? That's all I'm going to show you about R. It's just very simple, and I urge you to test this because if you're already messing in R, this is huge because once you structured tons of data, like GORD, like that, all that genetic stuff, I'm sure they're doing it from a CSV file, like an Access file or a Excel file. But if you store it in a database and you have like more data coming in, all you do is connect it again when the data are updated and just run this thing for whatever you want to do.
Yeah, I think Grant's diving into that right now.
Okay. Yeah, that's why I asked him about how I don't know anything about genetic data, and I wanted to. So again, with any fish that has derivative sampling, whether it's diet, age structures, or a genetic, what do you call it, a profile, a panel, that can get stored in Access instead of having a bunch of things come back from the vendor, whoever processed that in Excel or whatever. And then if you have like a whole genome sequencing, I'm guessing it's going to be a shit ton of records. You could basically connect to the database and then run all that. Most things have its own package, and there's these gurus out there that have all these complex packages that run stuff, and you don't need to know all that. Someone will show you how, or ChatGPT will. All right. If there's not a question, I'm going to shut this. I'll just get out of this. Actually, I'm going to shut it because R maintains a link to your database. And so if you're messing around, it acts kind of funny. So I'm going to go back now. We're going to start the simple age entry form. So we created a setup for this early on. So when you do data entry forms, it's not just data entry into a single table, right? So for example, if you have a survey, now, we're talking about from the field level now, because you wouldn't develop forms for importing data from other agencies. You would do it behind the scenes through queries. But if you have a form, that is the interface of your staff or whatever you have from unfortunately paper data sheets or the observation to getting it in your database, right? That's the interface. You don't need this if you already have data electronically. So recall we set up this query called query entry age. So here's something to consider when you create any queries that are supporting forms, always code them so that you have a block of code that are saying for entry or something else. That way you can, when you have to fix things, you can go to it. So what we're doing is creating an entry form to allow staff to enter ages for fish that don't have ages like these things. So we set up this query age, entry age. Hopefully you guys have that. And then we're going to create a form to go to it. So the reason we create entry stuff through queries is that this is an integration of two different tables, right? We don't have a data field in a table that's year. So if you're thinking about like we have this age data table, this is what it looks like. But this query looks a lot different because we also want to know when someone enters age from your data, you want to know what year or sample because it's sorted somehow. You know, they're not going to know, well, ID 10. You could do it that way, but usually your sample processing is organized either by year or survey and species. So that's why we provide these other attributes and set up the form. So you could see to have all of the relevant information that makes sense, you would have the sampling event, you would have which animal it's from or organism, and then you would have the data that you're going to enter. So this could be diet or whatever, tag information, for example. So we have that set up right there. And now I'm going to go to the form section. So we're going to go to forms. I already have this built. So whenever you create a form, there's going to be other attributes of this. So I'm going to use this as a model. So what we want to do is allow staff to enter age data by the sampling event, the operation ID. We'll just keep it simple for now. And year. So we want to know what year the data from and which sampling event. All right, we'll do it that way. So right now we just have year, and then we can also add a second drop list called lift ID. So if you have a ton of sampling events, you know, you don't want to just every billion things. You want it stratified by something that makes sense in the way you sort your samples. So what we're going to do is start with a new form, create form, and we're going to use, this time we're going to use the that one there. Oh, sorry. I clicked the wrong one. We're going to go to create a form design. There we go. So this is basically like everything else in this. This is the design view of something. And then there's a form view and a sheet view. So we'll go to the form view. So there's no form right now. So we're still in the design layout. So it's kind of like web developing. And the first thing we want to do is create a header area. So I'm going to open, this is what we want to build. We want an area where basically you have all the data that someone enters, but we also want the stratification things. It's just like everything else you've seen on your phones and the internet, but we can build this with in the context of your sampling. So what we want to do is right click here and we want to create a form header. All right. So we could do one of two things. One is we can create this drop list first. So under form design, there's all these different things you can customize and build. So what we're going to do, the thing you'll use most is a combo box and the subform. So I wish these were labeled there. So that's the combo box. What it means is it has a combination of type of ways you click it. So we're basically in the weeds of how you can build things in computer software, right? So these are all objects that are easier rather than writing code to do it. So a combo box allows you to create a drop list. So you can see that it's named combo 0. There's an object name. And then you have two choices for a drop list. So what we're going to do is create a drop list with the number of years in our sampling events. And if you recall from one of our earlier classes, we created a query that inventoried the number of years we have data. So basically, in the card one, we use the year function and inventoried the unique number of years. So we want that so that we can select years that are relevant to what we're sampling, not years in the future until we get the flux capacitor or something. And so next, what we're going to do is populate this list with an existing set of data. The other option is you can just type in your choices. So if you want like you don't have codes for something, you can actually type in the values you want. Like you can say, if you're asking about candy bars, Coffee Crisp, Hershey's, or, Almond Joy. But in this case, we're going to create something that's already in the system. So this is why it's important to name your tables with TBL or QRY. Right now it labels it. In the old days it didn't, so that's why we have this QR. So we're going to pick query QRY years and then hit next. And then it allows you from any query or table only pull the fields you need. So if we were to do this from like a code table, we probably don't want everything. Like for my species table, I have like 20 fields, right? I have kingdom, phylum, class, order, species, all that crap. We don't need that as a drop list. We just need to know the species or something. So in this case, there's only one choice, the year. And I'm assuming it's sorted, but you can force it to sort. So it gives you a preview. So in our data set, yours may be a little different because I'm a bit sloppy with the content I created. So there should be years of what's in your data set. And then you can name the combo box year. So that's a name, that it'll be a label, but it'll still be called combo 0 in the system. All right. So that's just a label attribute, right? So we are in object programming. So everything you look is object-based. If we were in linear programming, all of this would be written out in like SQL or VB, Visual Basic, and it's all like coding, and I don't want to do that. So what we can do quickly is just look at what that looks like, and then you can go and test it. And then right now it's just doing nothing. So you just created an object that creates a drop list. And we're going to connect it to our query so that we can actually bring up data. So now what we want to do is create a subform in the main area. And there's a subform report. You're going to drag it. And we're going to make it big because it's that query 3. So now you can access objects, and we're going to go to existing table and query. So again, we don't want to access the card3 age table because it doesn't have the year in that, right? It's only the lift ID and the age structure type. But we want that query because we want all the interesting information. So again, here's where it's important to have your things sorted. So again, we're going to go to query entry age. Notice it pulls up all the fields we want. So right now, let's just do everything. Next, it's going to name it subform 1 because I already have one. So yours will just say 1 without the subform, without the 1, and hit finish. All right, so we're going to make that bigger somehow. Stupid thing, depending on your screen size. So go ahead and look at the form view. So that's that query, everything in it. So there's 67 records. Now go ahead and try that. It doesn't do anything, right? So what this is supposed to do is if you pick 93 data, it'll just pull the 93, but it's everything because there's no linkage. It does. Right now you're designing this, and you got to create a linkage for that combo box to stratify and filter your data set. So we're going to do this quickly. So the way to do that is you click this outer ring, and I know there's another method to do this, and go to properties and go to data.
Sean, can I jump in so I don't get super behind?
Yep. Yeah, no worries.
It just didn't work for me. It's like just a plain white box that says query entry age subform in the top left corner without the actual like boxes for the fields.
Really? Okay. Let's step back. I'm going to redo it.
Okay.
Is it working for anybody else, or is am I just saying the wrong information? Anybody else have it working, or they're not doing it? Okay. Click on that. I'm just going to see. Let's walk through the steps in case so I can track what you're doing.
Okay.
Next, under this, we're going to go hit next. And then on this list, go to that query, entry age. Right there.
Okay.
Do you have all these things? If not, go to your query section and make sure you have that query.
I don't have ID number, but I have the other things. And actually, I don't have scale.
That's fine.
Yeah.
Because what it is if you go to your, I'm going to hit cancel. If you go to your query, it's probably not in there, right? You could just leave this open if you want. And all you have to do is just bring it down. Right now, it's not that critical because just make sure year is there. And I'm going to redo this. There. Okay, so I'm going to redo this, make sure it works for you. Form design. All right. And again, I'm going to go back to the query. I'm going to bring everything over, hit next, and then hit finish. And then you should get something like that.
Yeah, it did the same thing.
Okay. I'm going to continue, but if you can stay on after I get through this, then we'll troubleshoot yours.
Sounds good.
Okay. So what we did is we created this, right? There's no linkage. And here's the simple step to link the two. You just take basically, I don't know, there's another way to do this, but see how it's orange around the outside? If yours isn't like that, click that outer edge and then go to data under properties. So if you don't see the properties, go to form design and go to property sheet. Again, if you recall, we have properties for everything in this thing. It's very explicit. So there's two fields. This is really important to get this. There's a master field and a child field, and those are probably not appropriate anymore. Holy shit. So the master is this, right? This drop list is the master. And again, if you click on it, it tells you it's combo 0. And I'm going to go back to this thing. I'm going to type combo 0. And then the child, which is me, is the year. So then I'm so glad it's not case sensitive in Access because I would fail. So what this is doing, which is huge, and spent a lot of time thinking about it, is that this creates a linkage from this object to this object. All right. The master is that, the child is that. I'm curious what the new lingo is. So now it's 93. Notice there's not the other years. 25. Oh, there are no fish for 25. 92. All right. That's it. That connection, this little step is huge for you to design forms. Now, let's say we want to do a multiple one, and I'm going to do lift ID. So what I would want is a unique list of lift IDs that are non-repeating. So a quick way to do this is you don't have to set up a query because we know in card 1, they're all unique. God, I keep forgetting. You could do list boxes too, where, like there's different ones, all the things you see on your phone and internet, buttons and things, they're all up here. But I got to tell you, the combo box, which is not, is that the one? Damn. Okay. We're going to do a 2-layer stratification. So now I'm just going to grab card 1 abiotic data. I'm just going to grab lift ID. Right? It's unique. There's only one, and hit finish. Now I'm going to create a secondary link to that so that I can look at year and just lift ID. And so this thing is called combo 8. If you guys can tell me why it went from 0 to 8, I would love that. I just have lived with it for years. So again, we go back here. Now we're going to add a second level filtering of this, right? So you use a semicolon, and then you do combo 8. And then you, again, at the child level, you do ID number. Right? So now it's going to wait for a selection of year and lift ID and filter that down. All right, so let's make sure it works. So again, I only have one selection. That's why it's blank. So now let's say within 92, I want to look at operation ID 96. There you go. That's probably the most important thing, is to understand unbounded objects and how you create them as a bounded object. So that's using access terminology. When we first established these were unbounded, and now they're connected. It says unbounded, but it really is basically, or maybe I'm using the term wrong, but they're connected. The reason it's called unbounded is it's an independent object. It's not a table or thing like that. So when you start cleaning up forms, you're not going to want, like, we don't care, this is redundant. So what you can do is right click and hide these fields, right? So then now we know, oh yeah, for this species, lean lake trout, for this fish, again, who cares about the primary key? Let's get rid of that. We don't delete it, we hide it. Now, all right, for typically when you have age structures, in fact, you don't even need the species, but they can just verify what it is. Scale number 16 has an age, and then this is the age structure. So what it's doing is accessing the data through your query and showing you what is there. Now, if you wanted to restrict this even further for only data entry, you could basically do this in two places. So what we would want is any records with age of null. Then it would only bring up the fish that had no ages. That way your staff aren't overwriting your old ones. All right, does that make sense so far? And it's really powerful, and there's a lot of things you can do under the properties, because you don't want people coming in and typing in the wrong age. And I'm going to show you one other thing quickly and then hold off. So it's going to ask me to save it. So FRM, I always start with what category of form it is. So I'll do entry, age. That way I have a whole bunch of entry forms, because you can create forms for other purposes, which I'll talk about later. So what we want to do is have this species displayed, but not let them mess with it. So see how it's enabled or locked? You can basically hit enable, switch it to no. You can just type an N or just hit no. And if you go back here, see how it's grayed out? You can't even click in it. So they can't mess with it. But it's useful because it's referential, but then they can't mess with it. So if there's anything else you don't want them to mess up, like sample ID, you can again do that and gray it out. Again, let's go back to the design view for the scale. Now we want to go to the scale field, click on that. So the properties are over here. And again, if you don't see the properties, just go up here for scale, make sure it's selected, and then you just disable it. And then go back to design view. So to quickly, one last thing is, if I wanted this only to show new records, I can do this at the query level quickly. I just go here and put the age as null. Right. So we have age as null. We want scale ID, because there are fish that don't have scale numbers. We close this. So again, it's not refreshed yet. So we can either refresh all or close it and open it. So hopefully, well, that didn't work. Okay, let me go back. So now, did you notice the change? All the fish with ages are gone. All right, I'm going to stop there. I'll elaborate more on other features you can do. So this is the most rudimentary form design for post-processing. And I don't think I can do the seminar next week, but at the next seminar, we're going to build a survey entry form where basically you can enter a date, the data sheets from a field sampling event where you have some sampling event, operation ID, and you have a whole bunch of organisms and a bunch of crap with it. And I'll show you how to design it so that you can enter, the spatial stuff and the biological measurements. I did record this part, so hopefully it's helpful to you guys in doing the most simple form. So if you spend a little time thinking about it, you can think about how you would want your staff or whoever to kind of filter out stuff to enter things. Whether it's diet, like for example, our diet form is complex. We have like tons of surveys and agents. All right, I'm going to stop there with any new content. Any questions? I would like feedback from you guys. If you guys are going to test, which I think you might want to do, is connect access to R, because that same RODBC thing can connect to Excel too. Not that I don't know if that would be useful, but I just want to hear from others if you have trouble connecting, because I think that's a huge thing for the benefit of learning access in today's world. Is you're going to probably work in R a bit too.
So with digital data collection, do you need the forms at all, or does that step just get skipped and it writes directly into the table?
So a couple things about databases. Databases save instantly. There's no save button. So people worry about electronic data entry. Are you talking about like if I had this in the field on a tablet, I just type in the stuff? Is that what you mean? Or
just generally, like when you're transitioning to digital, do you still need to create forms, or they're just not used at all?
Well, no, forms are the only way you would enter data. If you think about everything you do in the world, when Amazon and everybody else collecting data, it's through a form, right? You're not going directly to the way they would manage data by entering stuff in here. Like it's a bit esoteric, and you have all the old data. An entry form basically set up for new information, or you can look at information around your new information, if that makes sense. So if you can build this, like I'm going to give you an example. I think I'll just do it with this class rather than my data. Let me see if I can find it, because this is exactly where you're going to head. And if you're students, you're eventually going to have a place where you're going to work that you're going to have to do this. Let me see if I can find this thing. I must have it in a different place. I want to show you it. This addresses your question directly. Hopefully I can find that damn file.
So if you're like entering biodata on new fish on the boat, you still need to do that through a form, not just like going straight into your biodata table.
Yeah, let me see
Okay.
if this is it. Okay, I'll just get to so basically in a survey, like for example, a typically sampling event, this could be fish or forest or whatever, stream fishing. You're going to go out and have all this spatial stuff, and you're going to have a whole bunch of fish to enter data, right? But you want to have codes and things that are meaningful, right? But if you were to enter directly to a table, like how would you do that? It would be all coded information, and then you'd have extra stuff, right? So yeah, the way you have to enter data from field sampling event is through a form, either directly in the field, like we do it by voice, we just voice it all in, or you would enter it with a tablet or a program keyboard, or you write it on paper and then you go through this form when you come back to the office and enter it. But if you don't create a form, then it would be hard to really get all your information entered, right? It'd be piecemeal. It would be clumsy and unstructured. So your job as a data manager is to build this to make it really simple for your staff. And they should know what 307 is. Who cares? If they know what's a lake trout, then they do that, or whatever mechanism they want to do. It shouldn't be coded for them. We keep it very simple. I don't know. Does that make sense? Because at some point, You know, if you guys are students, all you're going to be doing is importing data, or if you have students that are collecting stuff for you, you know, you would want to create something this. But if you're working in agencies, you know, this is the way you want your staff to bring in stuff, and you don't want them messing in your tables directly because they can mess up existing data.
Mm-hmm.
I don't know if that made
And then,
sense.
yeah, related question. Like how, when you, in the example we did the is null thing. So when you do
Yes.
enter an age, it's no longer null. So does that like disappear right away as soon as you type a number in?
Very good question. Remember I said this. Did you remember my thing where it was showing all of them still because I didn't
Hmm.
refresh? So a lot of these objects work in static memory or like RAM memory. So you have to refresh things, right?
Okay.
So for example, we'll just enter some data. And so right now it's filtered, right? So for this fish, I'm going to enter age, 34. And then normally you would have the age structure pre-populated because they're all odorless, and I leave it open so that they can say, well, the age structure code, it's actually bateritic, so they can change the odorless to a code meaning like it's messed up and they can't age it.
Hmm.
Or you should always have a notes field. So now, right, it's there and you can go through. But if I close this and go back to it, uh, wait, did I pick the right? I don't know. It might be gone. It should be gone. I guess I didn't keep track of which one I was on.
Can you also
Um,
click that refresh button up top
yeah,
that says
yep,
refresh?
you
Okay.
can. Yeah. In fact, I don't know what I did, but it should have been gone. But yeah, I don't see 34 here anymore. Do you?
No.
So it's only null. So you do refresh it. And actually, if you're building these forms, um, your staff are going to sit there with a bunch of envelopes, I'm guessing, or one fish at a time, and they'll enter this. But then when they come back the next day to do the next batch, these won't show up because it's
Hmm.
refreshed. Or you can actually write code in the background. For example, I don't know if we'll get to this, but for example, you can go to age, right? The properties, and there's a thing called event procedure. And you say on change, dirty, but after it's updated, you can go there and you can actually write a line of code. This is really out there, but after update, you can write some code here. I don't know what it is right now. I'm not. And then once you write that code, after that's updated with an age and you leave that field, it'll do something and you can make it disappear. Like you can have the event refresh, right? So you would access that function. Um,
Mm.
you would basically look up whatever it is. There's a function name for, where is that? Refresh. You would access that so that after this is updated, it would run the function refresh. Then it'll
Mm.
just disappear in front of their face. I mean, to me, it
Yeah.
wasn't worth that effort, but you could do that.
Yeah. It's cool to know the capability.
In fact, I would just ask ChatGPT to do it because I gotta figure out how to do it. Uh, yeah, that's what I would urge is if you have a question like that, you just write it out in ChatGPT. It'll tell you how to write that VB code.
Hmm.
In fact, we could do that after I shut the recording here. Um, okay. I think class has ended. Everybody's gone except for you two. Do you guys have any questions? I'm gonna
Just
stop.
troubleshooting why my
Okay.
form didn't work, unless you have other questions, William, first.
All right. I'm gonna stop recording then. I missed the beginning.